Welcome you to the second session on time value of money. So today, today's session we will discuss about the frequency of compounding and how to calculate the present values and the continuous compounding and the rest of the time value of money concepts along with the cash additivity principle. Right. So now we will move on to the frequency of compounding. So as I have explained you previously, so there can be several frequencies of compounding. That means sometimes you can have the things, you can have an investment that pays you interest annually, right? So sometimes you can have interest that can be paid more than once per year, right? So that means interest can be paid in monthly time period, in monthly frequencies. Interest can be paid in semi-annually, that means twice a year. Sometimes interest can be paid quarterly, that means in 3 months' time. Sometimes interest can be paid daily, weekly, likewise. So, if so, as I have explained you previously, so you can't calculate or you can't take a periodic interest rate. I mean, for the whole period, you cannot take an interest. So, if the frequency changes time to time, if the frequency of receiving interest is more than one time per year, you have to calculate the frequency of compounding. So, what do you mean by the frequency of compounding? With more than one compounding period per year, the future value formula can be varied than the future value formula which we took previously in the first scenario, right? So, normally, if the frequency or the frequency of compounding or the frequency of the interest paid is only one time per year, then you are using this formula, right? If not, if the frequency or if the interest is paid more than one time per year, if it is annually, if it is semi-annually, if it is not annually, and if it is semi-annually, quarterly, weekly, monthly, daily, then what you have to do, you have to use this formula in order to calculate the frequency of compounding and to calculate the future value of that particular investment, right? So by looking at the previous slide as well, right? So the previous formula is right. So if the frequency of compounding is if the frequency of compounding is only one time per year, then what you have to do, the formula that you are using is this: future value equals present value into 1 plus r to the power n. That is where the frequency is only for one time period, right? So you're having an investment and it gives you interest annually. However, if the interest rate is calculated more than once per year, then you have to use this formula, right? That is the frequency of compounding and calculation of the future value formula. Here, if V in the sense, that is the future value of the investment n periods from today. That means simply that is the future value. And PV is the present value. Right, so that is the investment or the principal investment that we are using for the particular investment or the first investment. And RS is the uh, stated annual interest rate. As I told you previously also, if only if only interest is paid for one time per year, interest is paid only once per year, then you can straight away use this R. That is why we have used this R straight away. However, so then it's known as the periodic interest rate, right? So I have explained that previously, right here, this one. So institutions often quote an annual interest rate than quoting a periodic interest rate. If the interest is paid more than once per year, then then an annual interest rate is quoted than a periodic interest rate. Right? Then that is also known as a stated annual interest rate. Then if in this scenario, as the interest is paid more than one time per year, you have to take the stated annual interest rate. So let's say if the interest is 12% per annum, then if the interest is paid monthly, what you have to do, you have to deduct this by 12 and then take 1%. That is the stated annual interest rate. And that stated annual interest rate is used for the calculations. That is this RS, right? And M, number of compounding periods per year, right? M is the number of compounding periods per year. Here you don't have in this formula you don't have that kind of a scenario in this formula, because the interest is compounded annually or once a year. Then you don't have that number of compounding periods per year. However, the frequency of compounding is there, or the frequency of compounding is more than one time per year, then you have to calculate M, right? You have to deduct this RS by M and plus 1 PV, and the whole thing is a power of Mn. N is the number of years and M is the compounding period, right? So that is how we are going to calculate this. So here we are given an example. Suppose you invest 10,000 rupees in a deposit with 2-year maturity and provide the stated annual interest rate of 8% compounded quarterly. So when you read a question like this, you have to get an understanding about all these values, right? So by reading this, you can identify this 110,000 rupees. That is the present value, right? With a 2-year maturity. That is the number of years. So you can put N. Right. So when you're reading the question, in the examination, you can put these notations. Then it will be easy for you to do the calculation. Right. In 2 years maturity and provide a stated annual interest rate of 8% compounded quarterly. Right. 8% is RS and compounded quarterly is M. Right. Compounded quarterly is M. Then by looking at these things, you can get the answer. Right. So I will show you how to calculate this answer. Right. So when we are using these type of questions, it is better if you can write the notations here. Right. Uh, PV is 10,000 and RS is 8% and M is compounding quarterly, in the sense 3 months. There are 3 months for a quarter, then there are 4 quarters per year. Then you put 4 and N number of years is 2. Then the formula should be written. Right. The formula is FV equals PV 1 plus RS divided by M to the power MN. Right. Then 10,000 into 1 plus 8%, right? 8%, then 8 divided by 100, then that is 0.08. 0.08 divided by M, because there are 3 months per a quarter and there are 4 months, 4 quarters per year, and to the power Mn. M is 4, N is 2. Right. Then we can simplify this. Sorry. 1 plus 0.1 plus 0.08. No, we will straight away write this. 1.17165.9, then multiplied by this. This is the answer. Right? However, when you are simplifying this part, right? There are some steps that you need to follow. Firstly, right, you have to solve this part. So you have to follow the BODMAS rule. Right. Then you have to firstly solve this. That is, divide 0.08 by 4. Then you have to add this. For the simplified value, you have to add this. And then for this, then you have to, for the whole simplified part, you have to put the power of 8, right? And finally, you have to multiply by 10,000. That is done in here, right? Firstly, you are solving this, right? And then for the solved amount, you are adding 1. And for the whole thing, because it has parentheses, so you have to put the this power of 8 to the whole brackets amount, right? Then you will get the answer of 11,716.59. That is how we are going to do this type of a calculation, right? So with that, we will move on to another question. It says on 10th July 2019, you borrowed $10,000 from your aunt. If you agree to pay a 12% annual interest, calculate the total amount you must repay if the loan is for 1 year and if the loan is for 18 months. Right, so I will explain and do the calculation with you. So I request all of you to do the calculations by yourselves in order to get a better understanding. Right? Then, so I will read the question again. It says that on 10th July, you borrowed 10,000 rupees from your aunt. Then your borrowed amount or the principal amount is or the present value is 10,000. And if you agree to pay 12% annual interest rate, that is R is 12% annual interest rate, calculate the total amount you must repay if the loan is for 1 year, that is N is 1, that is the first part, and the second part, N is 18 months. Right. And so we'll firstly calculate if N is 1. Then if N is 1 and the annual, you're calculating the interest for 1 year. So then what will happen? You have to use the normal formula. Future value V equals present value into 1 plus R to the power N. And then you can substitute the values 1 plus 0.12 to power 1 because N is 1. Right? Then you can simplify this 1 plus 1, 2 to the power 1. Then answer will be 11,200 rupees. 11,200 rupees. Right. So that is simple because N is also 1 and the interest is for 1 year. However, when you are doing this, the second calculation, right? Present value is 10,000 R. Here you cannot straight away take R because I know you will understand because you have certain like the interest is given as 12%. However, 12% annual interest rate. However, the loan period is for 18 months. Then you have to calculate the annualized interest rate, that is R divided by the number of months. Here you have to take the answer in months. So you have to convert the interest rate for the interest that is given for months. Then per month it is 1%. Right. Then you have to calculate this by present 1 plus R to the power N 10,000 1 plus 0.01 the power 18%. 18 months. Right? Then 10,000 multiplied by 1 plus 0.1, 18 months. Then the answer will be 11,961.47. Right. Then this will be the answer. However, I'm pretty sure that you might have a doubt that how can we like use the same formula here, right? Because same formula here, because we have previously learned a formula for frequency of compounding like this, right? So you have to have an understanding that we cannot use this formula because here there's no frequency of compounding. Here only the number of periods changed. Therefore, you cannot use this formula. What you can use is the formula this. This formula is only be used. Right. Then, yeah. Then let's say if there's another example like this. So uh, you have deposited or the present value is 3,000 rupees, or the deposit amount is 3,000 rupees, and the annual interest rate OR is 4%, and that is compounded quarterly, right? Compounded quarterly. That is, for a quarter we have 3 months, then for a year we have 4 quarters. Then M is 4. Then number of years is 5. Then what you have to do is here you can clearly see that it is compounded quarterly. Then you cannot use that previous formula. The formula that you can use is this. Right. R is 4%, 0.04 divided by M, that is number of compounded periods per year, that is 4, into MN, right? Then, just like in the previous scenario, right? So you have to solve this part first, right? And then add this one, and then power sign, and then this. Then the answer will be 3,600 rupees and 3,660.57. Right. What you have to remember is that you have to follow these signs, right? Or these steps when you're solving the equations or solving the formulas. Otherwise, the answer will be wrong. With that, we will move on to the next part. That is also frequency of compounding with continuous compounding. Then you don't have a number of compounding times. Or previously we talk about the frequency of compound. When we talk about the frequency of compounding, I told you that there can be more than one frequency or one time where the things are interest is compounding, right? Firstly, In the first or the basic scenario, we told that you have frequency of one time per year, and then it gradually increased up to 4 month, up to semi-annually, quarterly, monthly, daily. Likewise, however, in this scenario, what you can see is you have continuous compounding, and the compounding periods per year becomes infinite, right? So you cannot control that. So you cannot control that, and you cannot measure the amount. So at that particular situation, what you say is that the frequency of compounding is becoming infinite, and at that point in time, the formula that you have to use when you're calculating is this. Is this. Here you can see the future value is there and the present value is there, and another notation can be seen, that is E, right? E is a constant, so you can see the E's value. Here E is constant and R, S and N. And so all these things are like same as previous. However, um, what you need to do is you have to have an understanding about the time periods. So when you're reading the question, if the frequency of compounding is continuous, so the formula that you need to use is this, right? Uh, yeah. So here also you are given a like a question, right? It says suppose you invest 10,000 rupees in a deposit with 2-year maturity that provides interest of 8% compounded continuously. Compute the future value of the investment. So if that kind of a question is given to you, what you have to do is you have to use this type of a this not type of this formula. So you can see 10,000 rupees, that is the present value, and with 2 years maturity, that is N, and provides a compounded continuously, right? Then that is the time you get the idea of the formula that you need to use, and the interest rate is 8%, right? R is 8. Then I will use this formula and explain you how to do this calculation, right? Future value equals present value E R S N. This is the power sign, right? The you have to like this part should be a power of this, right? Then future value equals present value 10,000 into E 10,000 into E. R is 8, then 0.08 to 2 years, right? Then here, how we are going to calculate this E? Either you can use this, right? So otherwise, if this E is hard for you to like find, so remember, so what you need to do is you can use your scientific calculator. And another thing that I need to tell you is that uh, when you're doing the calculations for the exam, you're required to take a scientific calculator. So in your scientific calculator, you can see a sign called alpha, right? Alpha, and and ln. Firstly, you have to press the alpha key, and then you have to press the ln. That is the natural log, right? So then you will get an get a E that is having a shape like this, just like an italic E, right? That E should be used for this particular calculation. Then after getting that E, you can put the power sign and take this multiplication over the power sign, right? And then the answer will be 11,735 rupees and 11 cents. Right. So that is the calculation that we are using for a continuous compounding. So here you can see the effect of compounding frequency for on future value $1 with stated annual interest rate of 8% on a different frequency of compounding. So the same scenario is given by using different compounding periods. Right. So firstly, you can see the annual compounding or the future value with an annual frequency of compounding, and you can see the future value with semi-annual frequency of compounding, and you can see the future value of quarterly, monthly, daily frequency of compounding. However, when you're looking at the continuous compounding, you can see that all the values, the future value of the continuous compounding is having the highest value. So therefore, you can conclude that when the frequency of compounding is increasing, the future value is also increasing. Firstly, when we are discussing about the future value, we talked that, or we learned that when the interest rate is increasing, the future value is increasing, and when the number of years is increasing, the future value is increasing. Here we are learning that when the frequency of compounding is increasing, the future value is also increasing. So in the bottom, you can see two formulas. The first formula, which is in the left hand side, shows you the formula that can be used when you're having frequency of compounding, right? And when a scenario is given with continuous compounding, the formula that you should use is the second formula, right? That is FV equals PV multiplied by E. E is taken by taking alpha plus ln, alpha and ln, and then that will be the power of ln and to the power of RF multiplied by n, right? These two things will be used as power. These two are power, right? So that is how we are going to uh, use these type of formulas, right? So then you are given a question that is yeah. This is the previous question that we took, right? So you can do that. That is yeah. And mm, yeah, this question that is given, yeah, these type of questions should be calculated. So firstly, we will calculate this. That is, if you invest 2000 rupee, $2,000 at an annual rate of 6% compounded continuously, calculate the final amount you will receive in account after 7 years. And the second question, if you invest $500 in at an annual interest rate of 10% compounded continuously, calculate the final amount you will have in the account after 3 years. Right. So firstly, we will do the first question. Right. This, if you have, yeah, I'm doing the first question. It says, if you invest $2,000 at an annual interest rate of 6% compounded continuously, calculate the final amount you will have in account after 7 years. Right. So then the present value is 2,000. Interest rate is 6% compounded continuously, and N is 7. Right. So then the formula that you should use is future value equals present value E RSN. Right. 2000 to E. Sorry. 2000 into E to the power of 0.06 multiplied by 7, which is the power. Right. Then by solving that, you will get the answer of $3,043.92. Right. So when you're solving this, as I previously told you, firstly, you have to solve this, right? 0.06 multiplied by 7. And then you have to take this, that is alpha and ln key, right? In the alpha, you can get this E, right? Alpha E and ln. And then you can multiply it by this. And finally, you will get this answer. Right. And in the second question, what you need to do is present value is 500, RS is 10%, and number of years is 3. Right? Future value equals present value E multiplied by E RSN. Right? 500 into E, that is alpha ln, into the power of 0.10 into 3. Firstly, you are solving this and then taking alpha E and taking this E and then this. And the answer will be $674.93. Right. This is how you take this answer. Right. So what you need to remember is that you should remember these formulas, because formula sheets will not be given. Right. So with that, we have concluded this present value part. So now we will move on to the present value calculation. Right. So firstly, we will talk about the frequency of compounding in single cash flows. So previously, when we talk about the future value, we told that I have told you that when we are going forward, so if in a timeline, you already know that zero is the today's value and the beginning of the year one or the period one. And when you are going forward, what we are doing, we are compounding, or we are going, when if we go to the future value, then we are compounding the cash flows. So here what we do is the other way around. Here what we do is the other way around. That is um, then that is when you're like, if you're in the future year, and when you're calculating the cash flows for today's perspective, then you're discounting the cash flows, or you're going backward, right? So that is mentioned here. When we find the present value of cash flows, we move the cash flows backward in time. The process of moving cash flows backward in time is called discounting, when interest is earned on interest. As I told you previously on the first lecture also, in the time value of money, we are calculating the compounding interest, or the interest on interest. When we are calculating the compounding interest, we are calculating interest on interest. When we are going forward in time, or when we are going forward with the calculations, then we are compounding, and when we are going backward in time, then we are discounting the cash flows. Right, so the same formula can be used, right? So you know what the formula which we are using to calculate the present value, right? That is FV equals PV into 1 plus R to the power n. Then when you are calculating the present value, so the same formula can be written, right? If V equals PV 1 plus R to the power n, then you are searching this part. Then how you are going to solve the equation? You are keeping PV, then you are taking this 1 plus R to the power into the other side. Then when you're taking that into the other side, then it will become uh, a fraction, right? This is the formula. PV equals FV divided by 1 plus R to the power n. This formula will be used to find what? The present value of the cash flows. And here I have given you some example. In order to obtain 105 in 1 year's time, how much you should invest today in the bank account, which paying interest of 5% annually. Right. So previously what we discussed was, we are having 100 rupees, and how much will that 100 rupees be in 1 year time period if the interest rate is 5%. Right. Then you are calculating the cash flows forward in time, or we are compounding. Then we are using this future value equals present value 1 plus R to the power n 100, 1 plus 0.05 into 1, then you are getting an answer of 105. Now what we are doing, we are having this 105, and if we need to have 105 after 1 year, how much we need to invest today? Then if we want to find the today's investment value, then always we are searching for the present value. This is the formula. Future value is 105 divided by 1 plus 0.05 0.05 to 1. Then it is 100. So this is how you do the calculations. Right. And the next one, present value of single lump sum. So previously also we have calculated for 2 years, right? In this question, now suppose you need 110.25 in 2-year time period. If the bank offers 5% interest and interest on interest earned is credited to your account annually, how much should invest today? Right. So then you are having uh, the a future value of 110.25, and the number of years is 2, and the interest rate is 5%. Then if you need to find the value that you need to invest today, what you need to do is present value equals future value divided by 1 plus r to the power n. Future value is 110.25. 1.05 to 2. Then you get the answer as 100. Right. Then we need to place the future value at 2, and we move the future value backward to time t. So if we draw this timeline, we have 110, and we are taking backward in time for time 0 for 100. Right, so this is a question. How much money you need to deposit today at 7% annual interest compounded monthly to have 50, yeah, this cannot be, done because this is a question that you need to do after calculating, after knowing frequency of compounding. Right, so in order to do this question, we will go to the frequency of compounding, right? Present value. A present value of frequency of compounding. Previously, we talked about the future value frequency of compounding. Right, I will write that formula. Right, so this is the future value frequency of compounding formula. Right, and this is the present value frequency of compounding formula. When you look at this, you don't see any difference, right? So you have to write the present value frequency of compounding formula, and if you need to write the present value of frequency of compounding formula, the present value is what you need to find is here future value, here present value. Future value is here, then 1 plus r divided by m and minus mn. Right, so that is the only difference here, a future value and minus mn. Right, you know that the present value is the present value of PV is the present value of investment, if V is the future value, R is the stated annual interest rate, M is the number of compounding periods, N is the number of years. And here I have given you an example. Suppose you have received 11,716.59 rupees upon the maturity of 2 years. Here, this is the future value. Maturity of 2 years is N. Deposit with stated annual interest rate of 8%, that is RS, and compounded quarterly, that is M. So you have to find the present value. Then this formula will be used. Right, I will explain you that, right? Future value is 11,716.93, I guess. 59. 59. And RS is 8%. M is 4 because it's quarterly compounded. N is 2. Here we are finding the present value. Then we can write the formula. Zero point 0.08 divided by 4 multiplied by 4, 2, and minus, right? The sign should be minus mn, right? Then you have to firstly solve this part based on the BODMAS rule, and then you have to add this and then to the power of this. Then you will get 11,716.59 multiplied by 1.2 power of 8 minus 8, and then 11,716.59 multiplied by 0.85, 0.85359, 10,000. Right. That is how we are going to do the equation. Right. Right. So we will move on to this question, which is in the slide. Right. It says how much money you need to deposit today at 7% annual interest, compounded monthly, to have 15,000 in the account after 9 months. Right. So here also what you can see is you can see that the amount or the future value you are required to get after 9 months is $15,000, and the interest rate is 7%. And now you are calculating how much money you need to invest today, right? For that also you need to use the present value formula, present value frequency of compounding formula, right? Present value or the future value, the future value is 15,000. R is 7%. M is 12 because it's compounded monthly and for 9 months, right? So how we are going to find 9 months? 9 divided by 12, then you get 0.75, right? And then PV equals FVN 1 plus RS divided by M minus MN. Future value is 15,000. 1 plus 0.07, 12, divided by M is 12, and number of compounding time per year. So why are we deducting this by 9 by 12, dividing 9 by 12? Because N is always number of compounding periods per year, right? So for year, it is 0.75. Then we are calculating this 1.0.058 into 9, 15,000 into 0.9489 to 14,206.99. Right, 14,234.99. Right, then this will be the answer. Same thing will be followed. However, you have to remind the formulas that we are taking for one by one. Right. Yeah. Then we have calculated that. And the next one is the cash additivity principle. So under this cash additivity principle, it says that you cannot add or subtract the cash flows that occurred in different times without adding or compounding or discounting them to the same time period. Right? That means you in the time value of money, we are equaling the cash flows that are that we get in different time periods, right? However, if we are talking about the cash, when we are talking about the cash additivity principle, it says that even though we receive cash flows in let's say cash flows in here I will draw this and show you, right? So you can get cash flows in different time periods, right? In today's time period, you can have 500. In year 1, you can have 100. And in year 2, you can have 1,000. And in year 3, you can have 700. However, in time value of money, you cannot add these things, right? You cannot add these things. If you want to add these values together, what you need to do, um, you need to discount or compound the cash flows. So if you want to take the value or the future value in or the value in year 3, what you need to do, you can add or you can take the value in year 3 just as it is, and you can take the future value of year 1 and year 2, right? If you need to like calculate the value of year 2, what you need to do, you need to take you can just take the value of year 2 as it is, and in order to take or in order to add the value of year 3, what you need to do, you need to discount that, or you need to take the present value of year 3, and you can take the future value of year 0 or year 1, right? Then only you can add these things. If you want to add or subtract the cash flows that you are taking in different time periods, you need to take all those cash flows into one single time period. Otherwise, you cannot add or subtract them. If you take all these cash flows into one time period, then you can add, you can subtract, you can do anything for those cash flows. If those cash flows are in different time period, you cannot add or subtract that without taking those cash flows into one single time period. That is known as the cash additivity principle. If you want to add the cash flows, you need to take those cash flows into the same time period. This is once those cash flows are in the same time period, we can add or subtract the cash flows resulting the equivalence of cash flows. That is known as the cash additivity principle. And this is a summary for all the things that I have explained to you, and that ends the second lesson, which is the time value of money.